Hi everyone. Today we'll be taking a look at question 64 on LeetCode called minimum path sum. So we're given an m by n grid with positive values, and we want to find the path from the top left, aka this one here, to the bottom right, which is this other one here, which minimizes the sum of all numbers along its path. And we can only move down or right, so no diagonal stuff. Cool. So this is a classic dynamic programming question. What we'll do is we'll calculate the minimum sum for every single element inside the board. And so by that logic and algorithm, we'll have the minimum sum by the end. Now, how do we do this? We can traverse from left to right and top to bottom, meaning that every single new tile we come by, we'll just choose the minimum between its left value and its right value, which are the two previously visited values in our iteration. As for edge cases, since we have the first row and the first column here, obviously they only can go one way. So we'll update those first, and then we'll update the inner for tiles in this case. So let's update the first row and first column first. And actually, let's start at 1 since we start updating by the second tile. We can say grid 0, 9 plus equals grid 0, I minus 1. So this will update the sum for the first row. Now let's update the first column. And we'll say grid I0. Just make sure that's correct. Grid I0, yep. This equals grid I minus 1, 0. So once again, this will just update the first column. Now what to do is just update the inside. So since we're starting at the first index of the row and column, we'll say for let I equals 1. And for let j equals 1. We'll update every single one by choosing the minimum between its left neighbor and its top neighbor. Why do we not take a look at the right and bottom? Because once again, we are going on an iteration from left to right. So we can only choose between elements that have already been visited and tested. So in this case, since we haven't updated this 1 or 2 yet, we can't consider it in our in our update here. We can only consider this value and this value has been updated. So as I said, we choose the minimum, so we say math.min between the one above it and the one to the left of it. So this will just continuously update every single element until we get to the bottom here, at which point we can just return the last element, which is just denoted as that. Cool. So let's see if this works. Works just fine. And works just fine. Cool. Let's talk about runtime. These are both going to be O of n and m, where n and m are going to be the length and width of our matrix. But the bigger iteration happens over here where we visit every single element inside. So worst case, this is a of, n times m, where n and m are the length and width of the grid respectively. So once again, the logic behind this entire question is just updating every single element with the cumulative sum up to that point. To figure that out, we always choose the minimum between its left and top neighbors, and that's it. And you keep iterating until you reach the bottom. This is considered memorization, by the way, because we are using previous results and choosing one of them to update our current result. So with that, I'll put a link to the questions with my GitHub down below, and I'll see you guys next time.